This is the first video on the introduction to chemistry GCSE, and it's on the topic of atomic structure. So the first thing you need to understand about this topic is that you're going to learn about some of the basics around the periodic table. And the periodic table is a table of elements. Now, an element is defined as any substance which is made of only one type of atom. So if you look at the pictures, you'll see that here we've got a copper tin, and in copper there's only one type of atom. They're all copper atoms. So copper is an element. Here is another example. This is carbon, or in this case charcoal, which is made of carbon, and that only contains carbon atoms. And both of these are examples of elements that are solids. But you can also have elements that are gases, in which case the particles are spread out far more. And so we can see here we've got helium, which is an example of an element again. It only contains helium atoms, but is a gas. If you've got a substance that's made of two different types of elements, then that is called a compound. And we're going to learn about how compounds join together in a couple of lessons. So that's the first thing you need to understand, what an element is and what an atom is. And when we use the word atom, what we mean is it's the simplest particle involved in a chemical reaction. So it's as small as you can break down fundamental particles. So what you need to be able to do at the end of this is be able to describe the structure of an atom, interpret data from the periodic table, and to be able to identify elements and compounds. So this is the first lesson in your introduction to chemistry on atomic structure, and that's where it fits into the overall module. So the atom. The atom has two main parts. In the centre, the atom has the nucleus, and the nucleus is made of two different particles. It's made up of neutrons and protons. Now protons, like the name suggests, P, are positive, and neutrons are neutral. And what we mean by this is we're talking about their electrical charge. So you can think of it just like a magnet, but instead of it being north and south, it's an electrical charge which is positive or negative. So protons are positive, neutrons are neutral, which means that they don't have a charge. They have a charge of 0. And around the outside of your atom you have shells or energy levels, and in these shells you'll find electrons, and electrons are negative particles. So just like magnets, opposites attract. So the positive protons are attracted to the negative electrons. Equally though, just like magnets, the same charges will repel. So in the nucleus, because we've got all these positives together, if that was the only particle that was there, the nucleus would explode, because all the positives would create a force that would act outwards and would make the nucleus decay. So the job of the neutrons is they're sort of like the best friend that holds the group together. The neutrons are there to provide a force that holds the protons in place, so they hold them in the nucleus. So you've got three main parts. You've got the nucleus, which has protons and neutrons, and you have the shells around the outside, which are electrons. And in between this area here, this is all empty space, so there's absolutely nothing in that region. It's just complete empty space. It's a vacuum. So the key things that you need to know about the atom are you need to know the three particles, proton, neutron and electron, and you need to know where they're located. So that protons and neutrons, these are both located in the nucleus, and the electrons, those are located in the shells around the atom, and we'll look at how they're arranged in those shells next lesson. You also need to know their electrical charge. So remember, protons, think of the P for positive, neutrons are neutral, so they have a 0 charge, and electrons are negative. Okay, they've got a -1 charge. The last thing you need to know about these particles is their mass. So if we compare their sizes, protons and neutrons are about the same size. If you put one next to each other, you wouldn't be able to tell the difference. So we say that they both have a mass of 1. Okay. Electrons, however, are far, far smaller. They're 2,000 times smaller. So compared to a proton and neutron, an electron is really, really small. Now, you don't have to remember this number exactly, but you do need to know that protons and neutrons are the same size. So if you had this table in an exam question and there was a number missing, for example, so they didn't show you the neutron, then you would just write 1 because it's got the same charge as a proton, so same mass as a proton. Make sure when you write the mass column, don't put plus or minus, just leave it as a number. And in the charge column, you must put plus or minus because it's either positive or negative. The other thing you need to know about the atom is the size, which is the radius of the atom. So the distance from the centre to the electrons is 10 to the minus 10 metres. So that's 9 zeros, 0.09 times, and then a 1. So really, really small. And the mass is even smaller. It's got a mass of 10 to the minus 23. You won't be asked to remember these numbers, but you might be asked to recognise them. So just remember the 10 in particular for the radius. So this is the periodic table, which you've got to be able to use. This is the periodic table you'll get given in your exam. And just to sort of break a few simple things down, I'm just going to show you a simpler periodic table, which is this one. And you can see on here that all of the metals on the periodic table are on the left. So all the metals are to the left. To the right, we have our non-metals. And in this little staircase region here, there is ones that sort of are halfway in between, and we call those metalloids. So you need to know the difference between metals, metalloids and non-metals. So if I was to ask you what type of material chromium is, for example, you'd find chromium on the periodic table. It's on the left, so therefore you know it's a metal. If I asked you what sulfur was, you'd find sulfur, which has got the symbol S, and you'd see that it's a non-metal. So you can easily tell whether something's a metal or a non-metal. You also need to know a little bit about the bonding in these. So if I've got two metals, or one metal on its own, like copper and nickel, for example, if I was to react those two things together to form an alloy, because it's two metals, when I have two metals, they will bond together in a type of bonding called metallic bonding. So if I've got two metals, they will bond together and I will get metallic bonding. If I had two non-metals react together, like oxygen and hydrogen, which is over here, which is a strange place hydrogen is, but if I react oxygen and hydrogen together, like in water, so two non-metals, I'm just going to put non-M for metals, then the type of bonding that they would do is called covalent bonding. And we're not going to explain what covalent is now, but you need to know that word. So if I've got two non-metals, so any of these reacting together, or obviously hydrogen's included in that, then that will covalently bond. And the last one is if I have a metal and a non-metal. So if I was to take sodium and I was to react that with chlorine, then a metal and a non-metal, so I'm going to put an N and an M, so a non-metal and a metal, that would give us what we call ionic bonding. So you need to learn about these types of bonding as you do your GCSEs, but for the time being you just need to know them. So two non-metals is covalent, two metals is metallic, and a metal and a non-metal is ionic. Okay, going back to the periodic table, when you're using a periodic table, there's a couple of numbers you need to understand. So on a periodic table you'll have the symbol for the element, which in this case is C, which is carbon, and it always starts with a capital letter, and you have two numbers, a little number and a big number. Now the little number is called the atomic number. The big number is called the mass number. So the atomic number tells you how many protons there are in an atom. So in this case, carbon has 6 protons, because that's the number at the bottom. Okay, it's got 6 protons. So the little number tells you the number of protons in that atom. Now, in an atom, this sentence at the bottom is really important. All atoms have the same number of protons and electrons. So because I know carbon has 6 protons, that means I automatically know that it also has 6 electrons. And then lastly, what about the neutrons? If I want to know how many neutrons there are, what I do is I look at the mass number, and the mass number is the number of protons plus the number of neutrons. So to work out the number of neutrons, I have to take away the top number from the bottom number. So 12 take away 6, and that is 6 neutrons. Okay, let's have a look back at the periodic table for a second to see some other examples of this. So there was carbon, that's what we've just done. If we just do magnesium as an example, which is over here. So if I look in the periodic table, magnesium has an atomic number, the number at the bottom, of 12. So that means it has 12 protons, and because it's an atom, it also has 12 electrons. And to work out the number of neutrons, I do the top number, the mass number, take away the bottom number, so it also has 12 neutrons. Now they're not always all the same. If I show you lithium, for example, lithium, if you look at the bottom number, that tells you the number of protons. So lithium has 3 protons, which is always the same as the number of electrons, so it must have 3 electrons. But if I do the top number take away the bottom number, I'll see that it's 7 take away 3, which is 4 neutrons. So lithium has 4 neutrons. So in the nucleus, there would be 3 protons and 4 neutrons, and then there would be 3 electrons around the outside. So this is how to use the periodic table, which is a skill you're going to develop over the next couple of lessons.